So first thing, we start off with, we're looking again, this is how we find the exact value, sine, cosine, tangent, of a particular angle. And specifically today, it's going to be less than 360. Tomorrow we're going to come back. There are going to be angles that we're going to find that are greater than 360. And as I said before, we're going to just follow the 4 steps that are listed here, 1, 2, 3, 4, as they're written. So the first thing it says, draw the given angle. So the first thing I need to do is set up an XY coordinate, an x-axis and a y-axis. Okay? An x-axis and a y-axis. One thing I need you to understand is that we are not moving away from the unit circle. We are still with the unit circle. And in your minds, what you can do is picture this right here. Picture there is a circle. And what we've done is we've just pulled the x and y axis out. So everything that I'm drawing on this x and y, you will find located on the unit circle itself, okay? The circle just isn't drawn. But don't let that confuse you or hinder you or think, oh my gosh, this doesn't have anything to do with that. Absolutely it does. It's still my x-axis. It's still my y-axis. I still understand that out here to the right is how many degrees? 360 if I do a full circle, but if I don't even move at all, 0. Okay, up at top, due north is how many? 90. Moving over here to the left, 180, and straight down below, which brings me all the way around to 360. Perfect, very good. So the first thing it says is we want to draw the given angle. So it's 60 degrees. 60 is 60 is 60. That's pretty easy. Which quadrant is 60 located? The first, absolutely. And guys, I am like probably the worst drawer in the world. And so I'm not here to judge you on any of your sketches by any shape or form. So if you can at least get it in the first quadrant, roughly about where it's at, I'm certainly not pulling out a protractor to measure that, because that's really not the main point here. The point is that we understand which quadrant it is and going from there, okay? Somebody asked if they wanted to turn the lights off. If you want to do that, we can, if that's better. Okay. Thank you, Connor. Okay. Here we go. Is that too dark for you guys? No. Okay. Okay. So we're in the first quadrant. Now this is what we did yesterday. It says draw the right triangle to the nearest x-axis. Notice it says x-axis. That is where you're going to make a mistake if there is one to be made. You're going to have a tendency at times, not every time, but at times to draw it over to the right, to the y. Never, 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 never. Always down to the x-axis, okay? So, and it doesn't matter where on this ray you draw that down, but just do a little dotted line. And I know that that is 90 degrees. It's a perpendicular line down to the x-axis. Then it says to determine, so I know, well, let me back up. I know that from my initial side to this terminal side, I created an angle of 60 degrees. Okay, that's a 60-degree angle. Then it says determine which of the special right angles will be used. Well, I guess I didn't finish. Determine the reference angle. So the reference angle is the original angle that was given, which was 60 degrees. And at this x-axis here, how many degrees is this x-axis representing right here? 0. What's 60 minus 0? 60. So the point is, if I'm drawing any angle in the first quadrant, there's no subtracting going on. I'm just looking at 60 degrees. Okay? I'm looking at 60 degrees. So I'm literally finding sine of 60 degrees here. Now with that, we talked about our unit circle. Every spoke, every ray that comes out of the unit circle has a measurement of what? Every hypotenuse will always be what on a unit circle? 1. Okay? If you have, and I should have had you guys grab this ahead of time, my bad. If you have your special hints, grab that because you will need you will need that for this if you don't remember them exactly. It's our special hints. And I am looking at 60 degrees. If this angle is 60, then the one at the very top is going to be 30. And the side opposite of 30 is my short side. So this right here down below on the x-axis is my short side. So if the hypotenuse is given, and I want to get to the short side, looking at your cheat sheet, from hypotenuse to short side, what do? Divide by 2, so it becomes 1/2. And then from the cheat sheet, from the short side to the medium side, what do? Short side to medium side, you multiply by square root of 3. So this becomes square root of 3 over 2. So I just created the side lengths on that 30, 60, 90 degree triangle. And I'm looking for sine of 60. And according to SOHCAHTOA, sine is opposite over hypotenuse. So opposite is square root of 3 over 2 divided by the hypotenuse, which is 1. So my answer is just square root of 3 over 2. Now, that is finding the sine of 60, finding the exact value without using your unit circle. So by using your unit circle, I locate 60, sine is my y value, and sure enough, I did it correctly, square root of 3 over 2. So this is finding, what we have here is finding the same values that we did on our unit circle without utilizing our unit circle. Okay, let's look at number 2. First thing, just looking at number 2, what would you guys guess the first thing I would want to do on number 2? If it's cosine of 3 pi over 4. Get it to degrees. Perfect. Absolutely. To move it to degrees, I convert it by multiplying by 180 over pi. That's taking me from radians to degrees. My pi's cancel. Feel free to grab a calculator. Take 3 times 180, divide it by 4. And you get you should get 135 degrees. All right, so now that I have my angle measurement in degrees, I'm going to go ahead and draw my x and y axis. And 135 lies in which quadrant? First, second, third, or fourth? In my second quadrant. So I draw my ray. And I show an angle measurement that I moved from the initial side, which is the x-axis, all the way to the terminal side. That angle created by doing that is 135 degrees. All right, then, so that was number 1, draw the given angle. So I just drew my given angle. Then it says draw the right triangle to the nearest x-axis. So I'm just going to drop down a perpendicular line to the x-axis. Then I want to determine the reference angle. Where this dotted line touches to that x-axis is what degree? If I would extend this x-axis out, what degree is this? This is 180. Okay, so if that's 180, I'm going to take 180 because of what I'm looking for here is this reference angle inside. Now remember, I'm always looking for the angle. It's called a central angle coming out from the center out. It's always going to be this angle I'm looking for, never this one at the top. Always this angle down here. So to figure this out, I'm just going to take what the angle measurement is here on this x-axis, which is 180. Subtract it from the angle that I just drew, which is 135, and I find the difference. 180 minus 135 is 45. Now, let me give you a huge hint. If I'm asking you to find the exact value without a calculator and without using your unit circle. And you're to locate a reference angle. If that angle is not a 30 degree, a 60 degree, or a 45 degree angle, you've done something incorrect. Because our goal here is to get it to one of our special angles so that we can use one of these little tricks. So there's a big hint for you that if you don't get this to be either 30, 60, or 45, go back and look because you've probably made some type of a mistake. Okay, so that's a good check. So this is 45. All right, what do I know according to this little triangle right here? What do I know the hypotenuse to always be regardless of what the reference angle is? 1. Okay, so this is 1 because it's a unit circle. Now on a 45, if the hypotenuse is given, to get to the short side, what do? Divide by the square root of 2. So do just that. 1 divided by square root of 2. 1 divided by square root of 2. Since it's 45, since those angles are the same, my side lengths would be the same as well. I'm looking for cosine. Well, let me back up for a second. In this quadrant here, what we found, and I need you guys to understand the purpose of what we're doing. If the hypotenuse on this 45 is 1, that means this length from here to here is 1. So then this 1 divided by square root of 2 is also a length. So from here to here, when the hypotenuse is 1, is going to be 1 square root of 2. But wait a second. Need all eyes to see this, otherwise you might get this wrong, and this is a simple fix. If I'm at the origin and I'm moving left along the x-axis, what kind of numbers am I encountering? Good job, guys. I didn't know if you'd pick up on that. That's exactly right. I'm looking at negative numbers. So this 1 square root of 2 needs to be a negative. Now what about going up over here? Am I still positive? Yep. So anytime I move up, I'm positive. Anytime I move down, I'm negative. To the left, I'm negative. To the right, I'm positive. Okay? So now let's go back to what our original question was. I want the cosine. Cosine, according to SOHCAHTOA, is what over what? Adjacent over hypotenuse. So adjacent to this theta, adjacent to my 45, is negative 1 over square root of 2, divided by my hypotenuse, which is just 1. So my answer, so the cosine of 135 degrees is negative 1 over square root of 2. Okay? Questions on that one? Okay, number 3. Tangent, 11 pi over 6. And just like we had with number 2, our first step that we had was multiplying to get rid of the radian measure to get it into degrees. So on your handy dandy calculator, take 11 times 180 over pi. And you get that angle measurement to be I think it's 330 degrees. 330. Which quadrant? First, second, third, or fourth? Fourth. Good job. So we know a full circle is 360, so just not quite. I'm going to draw my 330. So starting at the initial side, angling around to the terminal side, I have created an angle of 330 degrees. But the angle that's in question is this one created with the terminal side and the initial side. That angle right in there. And just looking at that, what do you think that angle measurement's going to be? 30 degrees. How did I find that? Because this triangle is touching the x-axis at 360. So 360 minus 330 definitely leaves me with 30 degrees. Okay, so this angle right here is 30 degrees. That's my reference angle. And again, and this is sounding very repetitive, but we want to say it over and over and over again, the hypotenuse on a unit circle has always a length of 1. 30 degrees, opposite of that is the short side. And we just did all that. Opposite 30 degrees is 1 divided by 2. And where am I getting that? From my handy dandy hints. Hypotenuse to short, divide by 2. Short to medium, multiply by the square root of 3. So square root of 3 over 2. Do you guys notice that, like, I've never used on my unit circle, like, 5 square root of 7 over 12. I've never used square root of 5 over 6. These numbers are always going to be the exact same. It's very, very, very repetitive. When you were doing your unit circle, we basically copied the first quadrant over to the second quadrant, over to the third quadrant, over to the fourth quadrant. We're using square root of 3 over 2. We're using 1/2. We're using 1. We're using square root of 3. We're seeing those numbers appear over and over and over again. Now, sometimes, depending upon what quadrant we're in, some are going to be positive and some are going to be negative. So let's look at our positive and negatives in this fourth quadrant. Is my square root of 3 over 2 going to be positive or negative? Positive. What about my 1/2? That is going to be negative. Okay, hypotenuse 1 stays 1 always. You don't have to worry about that. Okay, that's always going to be a 1. So this becomes a negative 1/2. So I want tangent. Okay, I want tangent. So tangent is opposite over adjacent. Say what? Opposite over adjacent. Now don't freak out on me here. What I have is a fraction being divided by a fraction, and when I want to divide a fraction by a fraction, I multiply by the reciprocal. And look at how simple this is. And I mean that. My 2's, what happened to my 2's? They cancel, so I'm just left with negative 1 over square root of 3. Okay? I'm just left with negative 1 over square root of 3. So then my tangent of 330 degrees is negative 1 over square root of 3. The only thing that I'm looking at my 30 degrees is finding my side lengths. And once I find my side lengths, I can create the ratio that I need for the original problem. Okay, example number 4. I'm already in degrees. Actually, kind of leaving an easy one for the last. So there's no conversion that I need to do. I can go straight into drawing. 225 degrees, which quadrant? First, second, third, fourth? Which one? Third, absolutely. This is 180, this is 270, so I'll go about in the middle. Draw my reference, or draw my perpendicular line to the x-axis. So I'm looking for this angle right here, because that full angle is 225. I just want that little angle from the terminal side to the x-axis. That's the little bitty angle I'm looking for. So according to this x-axis, what degree measure am I at out here? 180. So I'm going to take 225 minus 180, and I have a 45-degree angle. So looking at my side measurements, my hypotenuse is 1. And on a 45-45, hypotenuse to the side, I divide by square root of 2. And because it's a 45-45, both of those side lengths are the same. And I'm going to the left on the x, that means negative. And I'm going down on the y, so that in itself is negative. Tangent is opposite over adjacent. They're my two sides. And what do you notice about the two sides? They're exactly the same. So what's anything divided by itself? Just 1. Is it going to be positive or negative? It's going to be positive because I have 2 negatives. So the answer is just 1. That's what I mean by the simplest one. And for note purposes, I'm going to do that. Negative 1 over square root of 2 divided by negative 1 over square root of 2. So tangent of 225 equals that.